Hello everyone, this is Gautam Iyer and I'll be taking you through the C2000 Launchpad. This Launchpad has two variants. The first one is with the controller F28027 and the other one is with the controller F28027F. So let me just show you the home pages of both the controllers. The first one being TMS320F28027 and the other one being TMS320F28027F. So the main difference between these two controllers are that the part number F28027F is enabled with InstaSpin FOC. So InstaSpin FOC is nothing but it's used for motor control applications and is used to identify, tune and fully control any type of three-phase variable speed sensorless, synchronous or asynchronous motor control system in just minutes. So in short, it eases your motor control. So that's the only additional part that is with F28027F part. The pinouts, it's pin-to-pin compatible, and if you see the Launchpad, both of them look alike, just that the parts are different. So this is the F28027 Launchpad, and let me just take you to the F28027F Launchpad. So both of them are exactly the same, just that the controller is the different one. So this is the Launchpad homepage, wherein in Launchpad homepage you can go through the starters guide and you'll get the hardware design files. Again, for the C2000 Launchpad, for all the hardware files you can download Control Suite, and in Control Suite you'll be able to find all the design documents. So let me just show you where the directory is. So once you're in your home directory, you can go down to TI, Control Suite, device support, F2802X. So this is where you'll find all the examples, the latest structures. So these are the examples for F2802X family, and let me take you towards the development kit, which is C2000 Launchpad. This is the one. So here you have the same examples being listed over here again, and this is the main for all the hardware files. So you can find all the hardware files here, wherein you have the PCB artwork and at the same time the schematic. So this is the schematic of the board. So you can find the schematic here. Apart from this, the main documents that you require while writing code is the data sheet. Let me take you towards the data sheet TI 2000 28027. So over here you have the F28027 data sheet, which will give you a brief info about the device. Apart from that, you have different user guides for different peripherals. Like for example, there's a user guide for ADC comparators, for a boot ROM, for ECAP, PWM, HRPWM, I2C, SCI and SPI, and system control and interrupts. So you have user guides for different peripherals. They all have been divided into different documents, and you can simply verify them. So over here I have downloaded everything, but let me just show you where exactly you can download them. So when it is for the data sheet, you can directly download the data sheet from here from the home page itself. And then for the other user guides, you can navigate to the technical documents, and just below the application notes you can find user guides. So in user guides you'll get the ADC and comparator user guide, the HRPWM, the I2C, EPWM, etc. So all the user guides for the peripherals are over here. So for any kind of a detailed studies, the register study, you have to go through the user guide. So these are the documents that you have to go through, and as I've already shown where exactly you can find the example codes, right? So you have two ways of implementing codes. One is the driver set and the other is structure. I prefer structured way, so you can find all the structured way examples over here. And again, it depends on your interest. You can go through both the way of coding. Both of them are pretty different, how you basically interface the peripherals. So these are for the driver based. So I prefer structure because I'm used to coding all C2000 controllers in structured way. So I prefer structured. Yes. So just let me just give you a brief info on what this Launchpad and what all is there on the Launchpad. So you have the USB connection, which is basically it is a USB to serial connection, and you just have to connect a USB cable to start the communication. You can load the program, you can debug the controller, you can program the controller using this USB connection. You have this FTDI serial to USB converter. Apart from that, these switches are very important, which I'll be talking about later. This is the boot switch, and you have a serial switch. This is the main controller, F28027 or F28027F, depending on the Launchpad. This is just a programmable switch which is connected to one of the GPIOs, and you can play with. Apart from the switch, you have 4 LEDs that you can toggle and you can program and you can toggle accordingly, and you have a CPU reset button. Simple clicking this button will restart your code and it will start from back from zero memory address. So it's for resetting. Apart from that, the most important part being you have few GPIOs, PWMs and ADCs on these header pins. So you can use these connectors, and you can use kit wires to basically tap these connections and use this card as a control card, in short. Yes, so let me talk about the 2 switches, that is the boot switch, boot selection switch, and your serial connection switch. So let us go back to the schematics, wherein this is the switch S1 and the switch S4. So the significance of S4 is like when you're doing a COM connection with the terminal app especially, so you need your lines to be enabled, SCI RX and SCI TX. So you have to keep the S4 in on position for a UART communication. Secondly, for S1, this is GPIO 34, TDO and TRST. So now it's like these are the boot pins, and you have boot configurations that you can go through in the datasheet itself. So in datasheet, let me search for boot. Yes, so these are the boot configuration, wherein if your GPIO 37, 34 and TRST as 0, 110, you are into get mode. So get mode is wherein you can run your code from flash also. You have a wait state, that is 100, 010 is booting through SCI, you have 000 for parallel IO, and you have an emulation boot. So these are the boot mode selection pins, and the recommended is like 110 is recommended to be in get mode. So your Launchpad should always be configured to be in get mode. So just before giving you a demo on the CCS example and the Simulink example, let me just go through the parameters of the F28027 controller. So F28027 is a fixed point controller which has an operating frequency of around 60 megahertz. Apart from that, it has around a 64 KB of flash memory and 12 KB of RAM. The most important peripherals being ADC and PWM, it has around 8 PWM channels and around 7 to 13 ADC channels. So depending on which package. you're going for. It has one I2C, one SPI, and one UART, or one SCI is what we call peripheral for communication. So this is what it's all about, and it has around 20-22 GPIOs depending on the package again. And you have two packages, that is 38 pin TSSOP or 48 pin LQFP. So this is what F28027 consists of. And now let me give you a quick demo on how easy it is to code through CCS. I've already imported one of the program from Control Suite. Let me just show you where you can find this program. So it's like, as I had previously given you the address for all the structured examples for F28028 family. So you can navigate to this folder in Control Suite, and you can find this GPIO toggle program. So this is the project that I have directly imported, and after importing I have done a few changes which I'll show what I've done. So it's like over here you have an option of running 3 examples. As of now these two have been disabled. GPIO example 2 and GPIO example 3 have been disabled. The only one that is enabled is GPIO example 1. So what we do in GPIO example 1 is we toggle the 4 LEDs on the Launchpad. So Launchpad has 4 LEDs which is connected to GPIO 0, 1, 2, 3. So let me show you the same again. When we just go through the schematic, in schematic page number 2 will give you the idea. So GPIO 0 is connected to D2, GPIO 1 is connected to D4, 2 to D3, and GPIO 3 to D5. So these are the 4 LEDs on the Launchpad that have been connected to GPIO 0 to GPIO 3. So what I'm doing over here is, in GPIO exam I have commented what was there in the sample code. I have introduced just these 4 lines. What I'm doing is I'm toggling. You can either do a toggle, you can do a GPA set, you can do a GPA clear. So basically you're trying to set a GPIO or clear a GPIO or toggle a GPIO. So what I'm doing over here is I'm simply toggling this GPIO 0, 1, 2, 3. I'm giving a delay of around 1 second. Let me write it down. It's a 1 second delay in microseconds. And again, it's like this is going to be a forever loop. So it's going to keep toggling. It will be 1, then 1 second delay. Then it will be 0, 1 second delay. So these GPIOs will keep toggling between 1 and 0. So that's what we are planning to observe. So let me load this code. It's that simple. Nothing. We have not done anything else. We have done GPIO initialization. That's over here. We have initialized all GPIOs as outputs. So they all have been configured as outputs. And all of them are in GPA mux. We have selected everyone as a GPIO. So as simple as that. And you can go through example 2 and example 3. Instead of toggle, they use GPIO set, clear, and what they're doing is they're toggling all the GPIOs. So that's what I'm not doing in GPIO example 1. I'm just toggling the ones that is required for the Launchpad LEDs. So that's all I do. Rest everything is commented. So GPIO example 2 and 3 are not even running right now. It's only GPIO example 1 that will run. So now let me flash this code and show you the output through the camera. Let me flash. Yes, it's flashed. Yeah, it's flashing now. So let me show you through the camera. So this is what is happening. 1 second, sorry. 1 second on, 1 second off. So this is what is happening with. So I hope you got an idea wherein how simple it is to just toggle an LED. Rest when it toggle, okay. So it's like when it comes to the other examples, right from ADC SOC is code, especially it's like a PWM triggers ADC SOC, and you get the values. So let me just take you through the code so that you get an idea. So what we do over here is, it's like, this is the channel select. We select the channels. Like on the Launchpad we have ADC INA 0, ADC INA 1, ADC INA 3. We have number of channels, out of which we select few channels. Then we select the trigger, like what should trigger the SOC. So over here we are selecting EPWM 1A to trigger the ADC. So EPWM 1A with a particular frequency which is been mentioned over here, with a particular frequency. TBPRD is the frequency value. So with that frequency, that would be our ADC sampling rate in short. So this is what we set over here, and finally you get the result values in these variables. So this is an array which will have the result values. So this is how you can just explore all these example codes. You have a lot of EPWM configurations, right from deadbands and up counter, up down counter, etc. And you have I2C code, EPROM interface, and you have UART, SCI loopbacks, SPI loopbacks. So all these codes are there. You can just go through it. Any doubt you have, immediately you can just refer the user guides and you can clear your doubts immediately. Else not, you always have E2E forum, so you can post your query on E2E forum. So this is about the CCS. Now let me take you through the Simulink model. So what this model consists of is, like, it has peripherals such as ADC, GPIO, and your UART or SCI. So all of them have been interfaced with each other. Let me take you through the flow. We have an ADC channel which samples the input at every 500 milliseconds. It samples and then it compares with the mid value. So it just compares whether the value is, like, for example, the ADC max input can be 3.3. So it compares with its mid value, that is 1.65. So is it less than 1.65 or greater than 1.65? So this is where it checks whether it's less than 1.65. It's a 12-bit ADC. So the max value that we have is 4096. 4096 corresponds to 3.3 volts. So 2048 in short corresponds to 1.65 volts. So if it is less than 1.65 volts, what we do is we blink two LEDs, that is GPIO 0 and GPIO 1, we blink, and then at the same time we display the letter L, saying that it's less than 2048 to the UART. So this is what we're doing. At the same time, second, if it is greater than 1.65, we blink the other two GPIOs, that is GPIO 2 and GPIO 3, and then we send a command saying it's M, that is more than 1.65, to the UART terminal. So we'll be observing the data, especially the L and M character, on the hyperterminal app. So let me just show the configuration, the block configuration for ADC. ADC, it's in single sample mode. SOC 0 has been configured with 7 acquisition window. CPU timer is what triggers our ADC. There's no ADC interrupt generated, and it's at the sample time is at 500 milliseconds. The data type is UART16. These are the comparator blocks, and then we have GPIOs that have been configured as GPIO 0, and they have to toggle. So GPIO 0, GPIO 1, similarly 2 and 3 have been configured in toggle mode. And then 76 is the decimal value for the letter L, because ASCII is what is going to get displayed on the hyperterminal. So 76 is the decimal value for the letter L. So that's what we are sending to the MUX, and that will get displayed on the SCI terminal app. The header and the terminator is blank. It's just single inverted commas, open and close. So this is how it is. Let me show you a quick demo Let me arrange these things properly. Okay, so one is the terminal app, and secondly I need the camera to be on so that you can look at the output. So what I'll do now is, let me just burn the code now. Let me dump the code first. Okay, it's dumping. Let me open the terminal app. Yes, it's still building. Once the building is done, we can observe the LED blinking. So now the blinking has started. Let me switch on the connect switch. Now it says it's more or less, now it's floating. That's exactly why it doesn't know whether it's more than 1.65 or less than 1.65. So because during when the ADC floats, the values keep changing randomly. So now what I'll do is, let me show you the Launchpad. This is the cable of ADC that I'm holding, the green cable. What I'm going to do is I'm going to connect to 3.3 volt header, and it will show more M, right? You can see M, which means it's more than 1.65. Now let me connect this pin to the ground pin. It will show L, right? You can observe L. L means it's less than 1.65 because it's grounded, it's 0. Let me go back to 3.3. Sorry, let me go back to 3.3. It will show M. So this is what the experiment is all about, wherein now again it's floating, so it will give you random values. It will give you L and M randomly. So I hope you got an idea on how these blocks are configured and how you can observe the output. Thank you.